Hello friends, welcome to Coding Garden with CJ. Tonight's episode is Code Katas. Let's get right into it. So I did this last Wednesday and I plan to do it every Wednesday from now until I can't anymore, I guess. And the idea is I will be solving code katas, kind of talking through my process, showing multiple different ways to solve them, and also taking suggestions from anyone watching live. And I also have a GitHub repo under the Coding Garden organization called Code Katas. And there's an issue on here. If you would like to suggest a kata for me to do, you can throw it as a comment here. So we have two suggested ones, and I will give these a shot tonight. They're a little bit harder, so I'm going to start with something easier to kind of get warmed up, and then we'll jump into the suggested ones. And if you are watching live, please feel free to throw a message in the chat, and also suggest any katas in the chat if you have any suggestions. Also to mention, I am pushing up my previous solutions as well, so last week's episode, all of my solutions are up on GitHub, so you can take a look at those, and I will be pushing up these as well. Let's get right into it. I'm going to choose a 7 Caillou, and let's just pick one. Jaden-casing strings. I think this has something to do with, Jaden Smith. Jaden Smith, the son of Will Smith, is the star of films such as The Karate Kid and After Earth. Jaden is also known for some of his philosophy that he delivers on Twitter. When writing on Twitter, he is known for almost always capitalizing every word. Your task is to convert strings to how they would be written by Jaden Smith. The strings are actual quotes from Jaden Smith, but they're not capitalized in the same way he originally typed them. So basically you have to take a sentence and then capitalize the first letter of each word. I think this is a good warm-up problem. Question in the chat from pjo336. He just found my channel for view stuff. Pretty great stuff. Thank you, sir. Or ma'am. Or whatever you are. Sorry about that. And yeah, I am located in Denver, Colorado. All right, yeah, let's get into this. This should be a fairly easy one, and there's probably multiple ways we can solve it, so let's do it. Okay, this is an interesting one, though, because this is essentially adding a function to the string prototype. So you'll see how they're testing it. They declare a string and a variable, and then they actually call the function on the string. It's a weird way to do things, but essentially there are no parameters to our function. Essentially, we're just going to be operating on this. Let me pull this down locally just so I can show some examples of what we're talking about. So this is going to be jaden-case.js. So prototype function, and then we'll just have like the basic test that they have here. So like you declare a string, and then you want to be able to output it with every other word capitalized. Well, every word capitalized. So essentially, you create your string, and then you say to jaden-case, and this should return a string that is jaden-case. So let's say jaden string is that, and then we'll just log out the jaden string. Okay, but here's the idea though. So if you've never worked with prototypes, essentially inside of this function, we have access to the thing itself. Oh, you're located in Denver too. Awesome. But yeah, so it's a prototype function. So what I'm going to do is I'm just going to log this, and I'm not going to return anything. So because this function doesn't return anything, we should actually see undefined logged to the console there. So let's see it happen. I'm just going to run this file with node jaden-case, and you'll notice when that function ran, this is literally the string itself. So it's a weird way to kind of solve this instead of like a function that accepts a parameter. But essentially, now we just write our code that operates on the string in here. And if we actually return this, we're returning the string itself. So now instead of undefined, we should get the string itself. Yeah. And we might even do this .toString. Yeah, because then it's like an actual string. Okay. But here's how I want to approach this. I think I'll split the string on spaces, because essentially that will give us all of the words, and then capitalize the first letter of each word, and then join them all back together. Um, I'm thinking that, so like this solution I would probably do with like a split, a map, a join. We could just write this with a plain old for loop though. Here's what I'm thinking. Like if we do a for loop and we iterate through, every time we find a space, the next thing we find, we will capitalize and then continue on until we find a space. Let's actually solve it that way. We're going to solve it multiple ways. So this one's for later. But let's say this. So iterate over each character in the string. And first we'll need like a place to store the jaden-case string. And so we're going to iterate over each character. If the current character is a space, comma, we need some sort of indicator, like a place to store whether the next character we encounter should be capitalized. So we're going to iterate over, we're going to hit each letter. I guess we will always capitalize the very first letter. So we'll say like always capitalize the first letter of the string. And I am saying character, let's be consistent. So let's, instead of saying character, let's say letter, because that's like plain English. Okay, so iterate over each letter in the string. Always capitalize the first letter of the string, so maybe we even do that outside of the iteration. And then if the current letter is a space, the next character, so the next letter should be capitalized. And then we'll skip over it. Else, it means we've encountered another letter, so append either the letter itself or capitalized letter. Okay, let's turn this into code. So first, a place to store the jaden-case string. So let's just create a variable. Let's call this jaden-case. And we're going to initialize this to just the empty string. So it starts off with nothing. And then a place to store whether the next letter we encounter should be capitalized. So let's say let capitalize, and we'll initialize that to false, because initially we'll be encountering the first word, so we don't want to do that. Actually, I guess if we initialize this to true, then the very first letter we encounter, we will just capitalize it, because that's like the first letter of the sentence. Okay, so let's initialize that to true. And now we're essentially always capitalizing the first letter of the string. Okay, now iterate over each letter in the string. So let's do a for loop. So we'll set let I equal 0, while I is less than this dot length. So this is where this comes into play, because we're operating on the string itself. So this is the string, and it should have a length property. And then we'll say I++. We'll have our for loop body. And now we do the thing. So if the current letter is a space, the next letter should be capitalized. So let's say this. And let's store it in a variable. So we'll say letter is going to be this at the I index. So this will be the current letter. It'll start off as the first character. So if the current letter is a space, the next letter should be capitalized. So we'll say if letter is equal to a space, then capitalize is true. Else, we need to do this. Append either the letter itself or the capitalized letter. So we'll say if capitalize, then we'll say jaden-case plus equals letter to uppercase. It's a built function on a string. Case plus equals letter. So letter itself. Maybe they get tricky. Let's just make sure this is to lowercase, because we're saying to be lowercase. One thing I am forgetting though is if the letter is a space, also. So jaden-case and a space. And was capitalized, then we're going to set capitalized back to because the next letter we don't want to capitalize. I think that's it. Let's see. So let's in case. I think that's what we called it. Let's see. Look at me. I know how to program. So that's doing it, and doing it in one single. What we did was we capitalized the first letter, and then we said the next letter shouldn't be capitalized. But when we click the space, we know that the character we come across should be capitalized. Then we capitalize that. Everything else is lowercase. And then when we come across the space, the next one. So that does it. So let's see if code works it, and then I'm actually going to solve it with like a and a split. Let's this test. That of this. I realize I'm blocking this button. It's right there. So by the stream bit low, I was having internet for whatever reason, like internet connection. My internet was slow when I started streaming. Right now, okay, should be able to choose region, like down below. You can choose 1080. But yeah, and another comment in the chat. You can map a 4. So like. Which is why in JavaScript I'm gonna have to split it because I turn in an array so that map on it. Yeah, in Scala you can apparently. Interesting. But this is working, so we'll see. But let's do another one. I want to use the built-in methods. Basically, what I about earlier. Okay. The string on. So I'm just gonna split, and we'll split it on the space over it because us in the string. So this is word, and the thing we want to return is word. The first letter in the word dot to, and then the rest of the word. I believe there's a message slice which like substring, it will return a specific subword. Test it out real quick. I can go into like interactive node, and if I say hello, whoa, if I say hello dot slice with 1, that pulls off. So essentially, I'm take the first letter and make it uppercase, and then take the rest of it and append it. It should give us an array of capitalized words. And then we want to join it back to space, and then return that. So let's see. Run sample tests. It worked. Cool. If I had to choose a solution, this one looks. It's code. Maybe easier to follow if you know what app does. What I don't like about this is multiple iterations of the string itself. I'm saying the was choppy. If for anyone else, like if it's hard to hear me or understand me, please let me know. I don't want to hour and like a totally unusable stream. Is it that cutting in and out, or does it have buzzing on it or something? No. This is my break timer. Let's take a quick stretch. Yeah, so as I was mentioning, this is essentially 3 iterations. So this will iterate over to split it on the space. The map will iterate each word, and then we're going to iterate over to join it back together. This solution is a full iteration of the string. So we have loop, and it does all the work we needed to do in a single. Now, while this is more on bigger strings, it's probably more performant. We have less iteration. Cool. I'm gonna submit this. I'll save both of them and push those up to GitHub. See them as. Hopefully, I've accounted for everything. I do a quick roll. Cool. Pass test. Let's submit the final answer. Oh no! So it is the audio. I am just gonna restart the. Stay where you are. Will remain exactly the same, but I will be gone for like just a split second. Okay, I think I fixed it. Please let me know if I did not. But I solved this problem. And we can look at the previous solutions. So somebody actually did submit their very, like, a very similar way to the way I did it afterwards with a split, a map, and a join. Super interesting one. So this is just using a regular expression with a custom replacer function. Very cool. Basically, this says match any character that comes after a space and make it uppercase. That's a pretty cool solution. Sounding good? Sweet. Please let me know if it cuts out or sounds bad again. Awesome. Anyone watching live, any suggestions of some katas I should do? I am going to probably do one more 7 Caillou, and then I'll take a look at some of the suggestions from the repo. X's and O's. Let's see what this is about. Check to see if a string has the same amount of X's and O's. The method must return a Boolean and be case insensitive. The string can contain any character. Examples, input, output. This should be easy enough. I think we can maybe do this in multiple ways. Let's do it. Oh, I've already solved it before. Let's do it again. Cool. So this takes in a string, and then we need to count the number of X's and O's. If they're the same amount, we return true. If not, we return false. So I'll do this one local again. Let's do exes-os.js. And we need to be able to call it like this. So if I do exo with that, that should return true. And then we'll just log that result out. Cool. So here's my thought. We're just going to iterate over the string. We'll have 2 variables. We'll have x count and o count. And if we encounter an x, we'll increase the x count. If we encounter an o, we'll increase the o count. And at the end of it all, we'll just return if the 2 counts are the same. Should be easy enough. So we'll say let x count initialize that to 0, and o count initialize that to 0. And then we'll just iterate over the string. So start at the beginning of the string and then iterate. So while I is less than string.length, I plus. And so let's store the current letter in a variable. So we'll say const letter is string at I. And we'll say if letter is equal to x. Here's what we say: if it's equal to lowercase x or letter is equal to uppercase x. What we could do is just immediately set it to lowercase and then just compare that with a lowercase x. Or we could do a regular expression that just says, does it match x? Let's do that. So we'll say if letter.matches the letter x, and then that's just case insensitive. So if it's an x, then we'll say x count plus plus. Else, if the letter matches an O, case insensitive, then we will increase the O count. And then at the end of it all, we're just going to return, is the x count equal to the O count? Let's see what we get. Let's clear this. So this is called X's and O's. True. Cool. One thing I might do is like store this regular expression outside of the for loop, because this regular expression gets created every time, and it might make sense to store it out here. So let's say like const x regex is a new regular expression that is just looking for the letter x and is case insensitive. And then similar thing for O. So O regex, looking for the letter O, case insensitive. And then now we can just reuse that regular expression inside of the for loop instead of creating it every time. Cool. Should still work the same way. Cool. I guess another way to do this might be with a reduce. So we're essentially going to reduce this string down to a Boolean. We're going to keep track of the x and O count inside of the reduce, and then ultimately just return a single value from the reduce. I'm trying to think if we can do it in a single reduce, or will the reduce down to the counts, and then we just return if those are equal. I think we might do that. So very similar function, but let's do it with reduce. So I'm still going to store the regular expressions as variables, just because it's more expensive to create them over and over again inside of the iteration. But instead of this for loop here, we're just going to say we need to split the string so that we can use reduce. So split on the empty string, and then reduce it. And this is going to give us, let's say, the counts and the current letter. And then inside of there, we're basically going to do this. But we essentially want to store those counts on something, and that's what we're reducing to. So I am actually just going to create an object here that has x count, which is initialized to 0, and O count, which is initialized to 0. So essentially, we're going to reduce this string down to an object with x count and O count. And in our reducer, counts is exactly equal to this thing. So we could do counts.xcount plus plus, and then counts.ocount plus plus, and return the counts inside of our reducer. And then we'll store this in a variable like counts is equal to that thing. And then at the end of it all, we're just going to compare is counts.xcount equal to counts.ocount. Should do a very similar thing. We're just using a reduce instead of a for loop. Let's see what it looks like, and then maybe we can clean it up a little bit. So does it work? Seems to still work. Here's what I'm thinking. We could do destructuring. So essentially we can say this first parameter here, just grab out the x count variable and the y count variable. And we need that in curly braces. And then we can just increment that variable. I don't know if this is going to work, because this actually would like increment it in place. Okay. And then the thing we want to return is still an object with x count and o count. Let's see if this works. I'm guessing it might not. We might not need the extra parentheses here. Yeah, so this says like the first parameter, pluck out those two properties from the object. Count is not fine. Can I not do this? Can I not destructure only one parameter from a function? Okay, disregard me. Cool. So right now we're reducing this down to an object. I'm thinking if we take into account the oh, I called it count in the... Okay, good call. Let me go back to that then. Yeah, so this should be count. And then don't need the parentheses. Let's see. Cool. So that still works. Here's what I'm thinking though, because a reduce accepts the index. We could basically say if we're at the last index, instead of returning the object again, just return if they're equal. And then we can just return the reduce itself. Let's try to do that. So we have the reducer, the current value in the array, and then the index in the array. And so basically we'll say if index is less than string.length -1, then wait, that's the wrong thing. The if statement should be inside of the reducer. Good afternoon, Brett. Welcome to the stream. It's evening for me. I guess it's if I remember right, it's probably like around 1-ish, 2-ish p.m. there. So this is where we want the if statement. So if index is less than string.length -1. Yeah, because when the index is string.length -1, that's when we actually want to return the Boolean. We're just going to return the reducer thing. Otherwise, we're going to return xcount is equal to count. And now our reducer starts as an, like the accumulator starts as an object, but in the last iteration we return a Boolean instead. Let's see if this works. This will be very interesting if it does. Let's take a quick break. Oh, nearly 3 p.m. Cool. I don't think I've ever done a reduce like this, where basically like the accumulator is some other value, like an object, and then the last value we're returning is something else. Let's see if this works. It says true. Let's test it with some other strings though. Let's like test all of these. Actually, let's do this. We'll do console.log. So we should see all true logs, meaning that our function worked if this worked. Let's see. Hey, it worked. A comment in the chat, doing these in the DevTools console is not recommended. It's a lot harder because I think they actually released, if you do a new line in the DevTools, it should work. So like if I start creating a function thing and then do an open curly brace, yeah, if I do a new line, it actually knows that I'm inside of a function, so it'll let me. So that's easier. But if I ever accidentally press up, it'll go to like something I did before that. Yeah, so I like to do it like in more of a like an isolated environment. Yeah, so this is another way. I'm gonna submit this one. This one's interesting. I don't know if it's the best solution, but it's an interesting solution. Oh, nope. What's happening? Used to constantly, so you have to use var in the DevTools? Oh, right, because if you're overwriting your previous example, it won't let you redeclare a letter a const. Yeah, so you have to use var. definitely. Let's try it. So let's, whoa, too far zoomed in. Run the sample tests. That worked. All right, drum roll please for the final submission. Oh. Okay. Empty string contains equal amount of X and O. Oh, expected true instead got. So here's what we have to account for. If the string is totally empty, just return true. So if there is, so here's what we'll do. If the string has nothing in it, then return true. That was the one thing. I don't know if it said that in the description, but we'll see. Yeah, because essentially if it was an empty string, splitting it would be an empty array, so the reduce would just return the initial accumulator. So we need to make sure that we do that. All right, this should work. Drum roll again, please. It worked. Cool. Let's submit that. Okay, I think I'm gonna attempt the ones that were suggested to me. So let's do that. Cool. I believe this one is a lower Caillou than this one, so let's do this one first. This was suggested by Kaizen Media. He's in the chat every now and then. I don't know if he's in tonight. He might be watching later. But this is a problem called fat fingers. Freddy has a really fat left pinky finger, and every time Freddy tries to type an A, he accidentally hits the caps lock key. Given a string that Freddy wants to type, emulate the keyboard misses where each A supposedly pressed is replaced with the caps locks, and return the string that Freddy actually types. It doesn't matter if the A in the string is capitalized or not. When caps locks is enabled, capitalization is reversed, but the punctuation is not affected. Interesting. So essentially, anytime he types the A key, instead of having the A key in the final string, everything after that is capitalized, unless you reach another A key, which turns caps locks off, and then is lowercase until you reach another A key. Very interesting. Question in the chat, what do I do for work? Am I a freelancer? Right now, nothing. So I was an instructor of web development for about 2.5 years, and currently kind of like looking for my next thing and trying to build my subscriber base. Hopefully I can do this live streaming thing more often. I'm doing it pretty often now because I actually don't have a job. But eventually I'd like to be able to have some ad revenue and maybe have some online courses and be able to make money that way. Okay, so this is a very interesting one. Let's try it. Basically, every time we encounter an A key, everything after that is capitalized, but if we encounter an A key again, everything after that is lowercase. This is actually going to be a very similar solution to what I did for jaden-case. But instead of immediately flipping capitalized, it's going to stay capitalized. Let's do it. So let's create a new file. Call it fat dash finger. Is that what it's called? Yeah, fat fingers.js. So we've got our function. Let's take our tests. Whoa. I'm gonna turn off word wrap. Oh. Wow. So this string is so long that it wraps anyways. Oh, it's the second value. So there he is, Kaizen Media. Yeah, so he's the one that suggested this problem. Welcome to the stream. And we are just getting started on this one. So first, I'm gonna make these all be a console.log, and then we'll go. Well, don't know how that's gonna work actually. We actually just need to, replace parentheses, comma. So there, 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 and there. We want this to be parentheses equals. So basically, this is going to run our function and then make sure that the output from that is equal to that. So right now, this should all log false several times. No, that's the wrong one. Fat fingers. Did I save it? Oh, I put it in the wrong directory. Oh, Kaizen says it's 5 a.m. there. Thanks for tuning in. Really appreciate it. I think we can do this. You missed the very first one we did was one called jaden-case, and I think it's going to be a very similar approach. Essentially, we're going to look at every character in the string and decide what to do with the next character that we encounter. Okay. So if I run this, we should see everything false because our function is returning nothing right now. So let's try it. So here's my thought. We have a place to store the fat-fingered string, right? So this is going to be the string that we build up. And then a place to store whether or not the current letter should be capitalized. And this should initialize to false because when we start off the word, essentially caps lock is not on. And then we'll iterate over the string. And then we'll say if the current letter is an A, set capitalize to true, and else if the current letter is a capital A, set capitalize to false, else append the current letter, and then here we'll have to append capitalized based on our boolean. Cool. And then lastly, we'll return the fat-fingered string. So a question from Bob in the chat, can you pass by reference in JavaScript? The only thing you can pass by reference are objects, in anything that is an object. So like a function, an array, an object, those get passed by reference. Primitive values stay primitive values no matter what. So if you pass like a primitive value as an argument into a function, it's a copy of that value inside of the function. There's no way to modify the value that got passed in unless you passed in an object with value properties on it, because then you would be modifying the reference to the object. Hope that makes sense. But yeah, it's like if you're familiar with lower level languages, there's essentially a way to, on your parameters, say like pass by reference, and you can even pass primitives in and actually modify those primitives inside the function. Cool. But I think this pseudocode is going to get us there. So let's do it. So a place to store the fat-fingered string. So we're going to say let fat-fingered equal an empty string. And then a place to store whether or not the current letter should be capitalized and initialized to false. So we'll say let capitalize equal false. And then we're going to iterate over the string. So we'll say let I equal, let I equal 0 while I is less than string.length I++. And then we'll do all of this inside of there. Actually, that got rid of my indentation. I don't want that. Cool. Bob says my hair is looking extra voluminous. Voluminous this evening? Thank you. I'm thinking about cutting it. I don't know if I will. I don't know. Okay, so if the current letter is an A, set capitalized to true. So let's create a variable to store our current letter. So const letter equals the string at I. So this is the current letter in the string that we're looking at. If the current letter is an A, so if letter is equal to a lowercase a, then we will set capitalize to true. So we'll say capitalize equals true. Else, and really this goes here. So else, if the current letter is a capital A, then we will, well, oh, the comment needs to come after the curlies. Whoa, don't do that. So, yeah, so if it's a capital A, that means he has accidentally hit the caps lock again, so then capitalize is now false. And then otherwise, we will append the current letter to fat finger. And basically, if capitalize is true, we append a capitalized version of the current letter, but if it's false, we append a lowercase version of the current letter. Let's write this out with if else, but I actually want to do this as a ternary. So we'll say if, whoa, I have caps lock on. Cool. Okay, so if capitalize, then we'll say fat fingered plus equals the current letter dot to lowercase. Well, no, to uppercase, sorry. Okay. Else, I'm thinking, so I initially was thinking we do dot to lowercase, but if the caps lock key wasn't on and he did type a capital letter, then that means he meant to. So let's just append the current letter. Mention that there's a mention in the chat that he couldn't post his solution. Wouldn't look good in YouTube chat anyways. If you want to post a link to like a gist or a code pen, we could probably take a look at that. I will need to moderate the comments just a second. I can set the let's see. Actually, try to send a link in the chat, and if it doesn't go through, let me know, and I can see what I can do. But yeah, I'd love to see your solution either in like a gist or a code pen or something like that. Let's take a quick break. Okay, and I think this will do it. So yeah, we're pinning it there, and then lastly, we need to just return fat fingered. Cool. Let's try it out. True, true, false. So we did not. It didn't work for this very last one. Here's my thinking. Maybe this does need to be to lowercase. Whoa, 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 whoa. Nope, does not need to be to lowercase. I'm curious what I'm getting wrong. Let's log these two. Let's just look at these two strings side by side to see what it's actually testing for. And actually, here, let's do this. Let's just log my fat fingered version and then compare that to what it actually should be. Let's call this result. Equal that. And then let's log the result. And then let's store this as expected answer. Whoop, sorry, got double quotes. And we'll log the answer. because I want to compare what are we outputting versus what did it expect. Okay. That looks good. So we're comparing this one with this one. Where did we go wrong? Oh. Oh, we're not flipping. Are we flipping capitalize? Let's read the description again real quick. So it doesn't matter if the A in the string is capitalized or not. When caps lock is enabled, capitalization is reversed, but punctuation is not affected. I think that's the tricky thing. So let's see where we messed up right here. To protect it. So we reached a, so it should have went down, but we're not lowercasing at that A. Let's look at our code. So if letter equals lowercase a or uppercase a, and in the string, this is at and to furnish. So our input string is here. Let's look at it. So where's the first A? So we start, start capitaling inside of administration. So here we start capitalizing, and then everything is capital until we get to here. And then when we hit this again, it should go back down to lowercase. But it's not. Kaizen said he's kicking himself already, did so much unnecessary stuff. I mean, for some reason, I've gone awry, and I'm curious why. Have we flipped it? Okay. If the current letter is a lowercase a, then we need to flip it. Oh, doesn't matter. It doesn't matter if it's lowercase or uppercase. We just need to swap it like that. Because no matter no matter which one he hit, he accidentally hit capitalized, so it's not true false, it should be the opposite of what it was. Let's see if that works. There we go. Bob says, that's usually how I am when I face a problem. I'll have a million lines of code trying to accomplish one thing and it still won't work. Yeah, I mean, I highly recommend, like, before you even write code, it's kind of like break it down with comments like I did, just to make sure you kind of like have your mind around the problem itself, and you can solve the problem logically without actually writing code. Because if you can solve it logically, then it's a matter of turning that logic into actual code. Cool, and we can simplify this. So if we'll say if the letter is A or letter is uppercase A, then just flip-flop capitalize. And actually, I think it would make sense to call this caps lock. Right? And this should still be capitalized. Capitalized based on our blank. Cool. Okay, no worries. Yeah, I think in the future I want a convenient way for people to post, because it would be fun for as I'm solving things, people can post their solutions to the same problem as well. Maybe I'll make an app for that. That'd be cool. Yeah, so this is working. Let's throw this into Code Wars, see if it works, and then let's see if we can do it. I think we might be able to do this with a reduce. We can definitely do this with a reduce. Sample tests. It worked. Cool. Yeah, so let's try to do this with a reduce. Okay. essentially we want to take this string and reduce it to the fat-fingered string. So wherever you see a for loop, this is where the reduce is going to go. So we essentially want to return string. We'll have to split it to be able to use reduce. So split it on the empty string, dot reduce, and then this is going to be, the accumulator is the fat-fingered string, and the current thing will be the letter. And then our code from inside of the for loop can just go here. And at the end of all of this, we need to return fat-fingered. And fat-fingered starts off as an empty string. So going to end this, so oh, first there's another comment in the chat. I'm goofing around trying to use uppercase and lowercase to flip-flop between upper and lower. Interesting. So like almost like a functional programming approach. And then Kaizen Media says, going to end this one once and for all, king at refactors. Cool. Yeah, and then we can actually get rid of that. And yeah, so should do exactly the same thing. It's just a little bit tweaked. Yeah, so that still works. It's just tweaked to use a reduce instead of a for loop. The only thing here is like we're using reduce, but we still have this variable outside of the reduce caps lock. Technically, I could do like a similar thing that I did last time where like maybe we have an object and inside of that object we have fat-fingered and caps lock. And then if it's the last letter in the string, we just return the string itself instead of returning the object. Let's just do that. Because one of the ideas of like using a reduce is like this functional programming approach where you're not using any external variables. Everything is just inside of the reduce. So here's my thought. We have our accumulator, which is an object, and we'll have fat-fingered as a property on there. And then also we'll have caps lock, which is initially false. So then we can get rid of that. And then now we can destructure it. So we're pulling fat-fingered and caps lock off of the accumulator and then using them in here. And then we want to return an object that has those two properties. But we only want to return an object that has those two properties if the index, and we'll need the index in the reduce, if the index is less than string.length -1, so return our accumulator. Otherwise, we're going to return fat-fingered. Does it work? It still works. Cool. Cool, cool. Suggested in the chat, an app with a pin that's only released during the stream in the chat, like the live chat app with Chad. Can you expand, like a pin meaning like a password to get in? Or... Oh, okay. Or you mean like a live chat room, but you can actually like share code and stuff like that? But you have like a room code based on the current stream that we're in? Is that what you mean? Clarify. That'd be cool, actually. Yeah, so let me submit this one and see how we did. And again, I kind of made this point earlier, but this solution with the for loop is less iteration because we're only doing one pass of the string and we end up with the result, whereas the reduce has to do two passes because the initial split has to go over it and then the reduce itself has to go over the string. But let's submit the one with the reduce. Run sample tests. Still works. All right, drum roll, please. Attempt. So we forgot to account for the case where the string is totally empty. So expected, yeah, and can't read split of undefined. If you look at the instructions, if the given string is null, return null. If the given string is empty, then return the empty string. So let's do that. So yeah, basically we say if not string, well, if it's null, we need to return null. So if string is equal to null, return null. If string doesn't have a value, meaning it's empty, then return null. Okay, that should do it. All right, this is the one. Expected empty string. Oh, I'm using single equals, and single equals, I believe, will it coerce it? Let's see. If I do empty string single equals null, false. Expected. All kinds of things went wrong. So if string is empty, oh, that's why, because I'm returning null. I need to return the empty string there. Okay, so that fixed those. However, we're messing up here. So if the letter is either, we're going to flip-flop caps lock and then just return it. Otherwise, we've encountered the next letter and we want to append the current letter uppercase, otherwise just the letter as it is. I'm curious, will my for loop solution behave in the same way? Let's try it, because I could be doing something weird with my reduce. Let's take a quick break. Whew. Oh, that one's still failing. Let's log the input string. Hopefully it'll let us do that. So instead got BBB. So let's have a special case here. So before we return it, we'll say if string, well, if fat fingered is equal to the thing that we sent back, then let's log the input string so we can see why we're messing up. Hopefully that'll work. Whoa, okay, so this is the input string when that one's messing up. So we encounter A, then that should be capitalized. We encounter A again, so that should stay the way it is. We encounter A again, so that should stay the way it is. We encounter A again, so that should be capitalized. We encounter A again, so that should be lowercased. I think the tests are wrong. Yeah. I think their tests are wrong. Because look, let's break this down. Okay, so this is the input that we're given. And we're told if we encounter an A, then the next thing should be capitalized. So this should be capitalized. If we encounter an A, then now things should just be the way they are, so we should see a capital B. If we encounter another A, things should be capitalized, so that's capitalized. If we encounter another A, things should be lowercased, so that should be lowercased. If we encounter another A, things should be capitalized, so it should be like that. Based on my understanding This is the output we should get. However, it's saying we should get a lowercase b. Hello, Cassandra. Welcome to the stream. But it's saying we expected this instead. Let's go back. Okay, so yeah, Kaizen says he'll feel, yeah, I'll feel better if the tests are just wrong, but maybe we have a misunderstanding of how it should work. Let's see how they got this to work though. So if they pressed A, that means that this should be capitalized. If they pressed A again, then that means caps lock is off, so just that. This would turn caps locks on again. Yeah, let's try again. Okay. Caps lock. So this becomes B. Caps lock is off. So that just is B. Caps lock is on. That A would turn caps lock on. So the third character should be a capital B. And then this A would turn caps locks off, so that should remain a B. This would turn it back on, so that should be a capital B. I disagree with their expected value. Absolutely. I believe on here we can see, let's look in the discussion, see if there's, yeah. JavaScript translation, what? Oh, they converted the test itself. Thought it switched between two uppercase and two lowercase on everything, so AB. Yeah, my understanding was that, yeah, because that would basically just flip it right here. Like this would be dot two lowercase. And before, instead of just flipping caps lock, I was setting it like with a lowercase a to be true and an uppercase a to be false. But I don't think this will do it. Wait, this should be, yeah, two lowercase. Let's try this again. Let's see. Yeah, and then that breaks for all kinds of other things. I don't like this. I may skip this one. I may stop working on this. I'm very curious, like and I'm basically thinking like I'm not understanding the problem, because this is the expected output. So capitalize B, stay capitalized. Oh, if we encounter a capital A, caps lock stays on. I think that's the case. Yeah, so I think that's what this solution is telling us. So we start off with a lowercase a, and that turns caps locks on. So that becomes B. If we encounter a capital A, caps locks stays on. It doesn't turn off. But it doesn't. So caps lock stays on. And then when we encounter it again, it goes off. So that should be lowercase. We counter it again, it should go on. That should be uppercase. No, it's broken. I'm gonna say it's broken, straight up. I believe I can do something to, what can I do to unlock the solutions? Yes, show me the solutions. Okay, I think here's what I guess what we didn't account for then. If caps lock is on and the current character is uppercased, make it lowercased. That's not how caps lock works. Oh, yes, it is. Oh, I totally forgot. Because, like, okay. That makes sense. That makes sense. Okay. Yeah, because if caps lock is on and I'm typing here, great. But if I type a capital letter, nope. And caps lock is on, there's no way to type a lowercase letter with caps lock on. This is dumb. This is very dumb. Have this. Yeah, I don't agree with this. This is a very confusing kata. Okay, let's do this very last one. I think this is gonna be the last one I do on the stream. This was suggested by Andrea Schmidt. If you can solve this kata and get it to run without the timeout, you are my hero. Paste bin. Cool. So this is the paste bin ID. Let's look it up. Caps lock is on. Like, we can, well, I guess I closed it, but we saw the JavaScript solution for it, and they had some weird logic in there. Like, if caps lock is on and you encounter an uppercase letter, it's making it lowercase, and that is not how caps lock. I'm Bob. I tried it. Like, caps lock is on. Wait, caps lock on. If I press Shift and hit a letter, it's still capitalized. At least on this keyboard. I'm gonna write a strongly worded letter to the people. Is it just /ID? Cool. All right. So this is Pjo336 solution. So we've got our functions, which is 2 uppercase and nothing. And the current function is do nothing. So if the string is null, return null. Otherwise, split the string on the empty string. So it gives us an array. We're going to map over each character. Oh, I see what you're saying. So you had like another one in there, but now that it's only one, you didn't need multiple functions. If it's an A, then our current function will be, if it's 0, swap it to nothing. If it's otherwise, make it 2 uppercase. So we're basically flipping between not uppercasing and uppercasing. And then if the current function is less than 1, meaning it has an actual value, because if it is 1, then you don't want to apply on null. We're going to grab that function, which is going to be 2 uppercase, and apply it to this specific variable. Otherwise, the variable itself. So it's like either make it 2 uppercase or take the current value and then join the whole thing together on the empty string. Very interesting use of apply and an array of functions. Yeah, so Bob is saying there were some comments on that one specific, on the fat-fingered one, and the community was saying they shouldn't call it caps lock because it doesn't actually work like caps lock. That's okay, though. If I got that in, like, a coding interview, I would be so mad. I would be like, it's not what you described. Okay, but let's move on to this next one. Sum of pairs, suggested by Andrea Schmidt. Here's the idea. Given a list of integers and a single sum value, return the first 2 values, parsed from the left, in order of appearance that add up to form the sum. So basically, you're given an array and then some sum, and you want to return the two first numbers in that array that sum up to that value. So in this case, 3 and 7 sum to 10, so you want to return an array with 3 and 7 in them. But in this case, 4 and 2 add up to 6. 3 and 3 also add up to 6. And 2 and 4 also add up to 6, but you want the earliest pair, so you would return 4, 2. And if there are no pairs that sum up to that value, then you return undefined. And in this case, 5 and 5 is 10. However, 3 and 7 is also 10, and technically that comes before the second pair because those two values are before the last value. And so you would return 3 and 7. All right, let's do this. And the interesting thing about this is, like, you can solve it, but they test it with, like, really, really big arrays with, like, 10 million numbers in them. And so if you solve it in a certain way, that's going to time out depending on how you solve it. So let's attempt it. Whew. Sorry for the yawn. Bob said we should start a coding garden clan. I'm for that. You know how I do that? Let me just do that real quick. Qmite? What's Qmite? Don't know what a Qmite is. Can anyone tell me how to form a clan? Someone figure it out and tell me how to do it. Otherwise, I want to get started on this thing. So, let's create a new file in today's folder called some pairs.js. That's our function. And then our tests look like this. Get rid of that. Get rid of that. Instead of test.expect, we're going to say console.log, and that automatically converts it to a string for us. Let's take a quick stretch. Cool. And right now our function is returning undefined. So let's see what we get. If we run this code, say node some pairs, this is the type of question to induce full-on panic in an interview. I think so. I could think of kind of like the brute force way to solve it, and I think I'll do that first. But I've thought a bit about how you can optimize it. Basically, instead of having to do like a nested loop, we can do it in a single iteration. And that's usually how you get around these, not get around, but how you fix a timeout issue. Because when you have a nested loop, when you're dealing with an array of 10 million items, that's like 10 million times 10 million times. So it can be a lot. But if you just do it in one iteration, it doesn't grow as fast. Cool. So all of these are failing except for the one that returns undefined because our function is already returning undefined. So let's make it happen. And here's my thought. So we iterate over the array and iterate over it twice. So we'll say for each number in the array, iterate over the array, and if this value is not the outer value, add the two values. If they are equal to s, undo that. Let's give these a better name. This is sum, this is numbers. add the two values. If they are equal to sum, store them. And then after all of this, we will return the earliest pair. And we essentially need a place to store the pairs we encounter. Because if you remember, there's cases where, like in this case, or in this case, there are multiple things that sum up to that sum, but we only want the earliest one. So we probably want to keep track of the index of the second value in the pair. And then after we get all of our pairs, whichever one has the lowest second index, that's the pair that we return. Say lowest second index. And so we'll say store the numbers and the right index, because that'll be the index of the value on the right. You with me? Bob is saying if I go to account settings, I can put whatever I want in the clan section. I'll do that next. All right, let's do this. So a place to store the pairs. So let's just say pairs is an array. So every time we encounter two numbers that sum up to the sum, we're going to push them into this array. Cool. So for each number in the array, so let's do I guess we could do a for each. Can we do a for each? We're going to do a for each. And this is going to give us the, let's say this is the left number. Actually, I don't want to use a for each. I want to use a for loop. Wait. I'll use a for each on the outer loop. So left number and then inside of here, I need to go over the array again, because essentially I want to sum the current number with every other number in the array. Now I could just do like another for each or another for loop in here. So let I, let's call this right index. Start that at 0, while right index is less than numbers dot length. Right index plus plus. However, I don't want to start this at 0. First case, like if I start that at 0, I'm going to be adding the first number to itself, right? We'll take, basically if we're looking at an array like this, I would be adding 1 to 1. And then the other thing is, we only want pairs from left to right. So we want the pair 4 and 2, but we don't want the pair 2 and 4. So what we can do is this inner for loop should start at this index plus 1. So we want to add 1 and 4, 1 and 8, 1 and 7, 1 and 3, 1 and 15. Then we want to add 4 and 8. We don't want to add 4 and 1 because we already did that in the previous iteration. So this should give us our left index, and we want to start the right index at left index plus 1. So on the first iteration, left index is going to be 0, and then the right index will be 1, and so we'll go from there. And then when we get to 4, we'll go from there, and when we get to 7, we'll go from there. Cool. And then, yeah, then we don't really even need to compare it to be the outer value because we're already looking to the right-hand side of the number. So add the two values, and if they are equal to the sum. So let's just do that in an if statement. So if, and we can store the right number as numbers at the right index. If left number plus right number is equal to sum, and sum is the parameter that got passed into our function, then we want to store the numbers and the right index. And we're going to be doing that in pairs. So let's do like pairs dot push. We'll push in the pair, which is just going to be an array with the left number and the right number. and we want to keep track of the right index, because essentially whichever pair has the lowest right index, that will be the one that we return. Okay, so at this point, pairs, if we just log pairs, this is every single pair that adds up to that one thing. Let's run our code. So in our first example, 1 and 7 was the only pair. And then in this example, where we're looking for the sum of 2, 1 and 1 are a pair, but also 2 and 0 were another pair. But the one that we want are 1 and 1 because it has a lower right index. And then similarly on this one, so 5 and 5 sums to 10, but also 3 and 7 do, and that pair comes earlier, and it has a lower right index, so that's the one that we want to return. So that's what we'll do. So now that we have all of these pairs, essentially we want to find the earliest pair. So we'll say for let I equals 0 while I is less than pairs.length I plus plus. And we need a place to store like the final pair, just like that. And we'll initialize that to pairs at 0. Let's call this the earliest pair. And initialize that to 0. And then look at every other one in the array, so starting at 1. And we'll say if the earliest pair dot right index is greater than the current pair's right index, then we want the earliest pair to be pairs at I. And then lastly, we're just going to return earliest pair dot pair, because this should give us just the array of the things in it. The Caillou on this kata is 5 Caillou, and I guess that's harder than 6 Caillou. Yeah, so this is a tricky one, and I think probably because of the timeout issue. Okay, let's see if it worked. Cannot read property pair of undefined. What happened? Oh, if there are no... Okay. If pairs.length is greater than 0, then we do this. Otherwise, just return undefined. Meaning we didn't find a pair. Cool, and that works. So we get back the actual pair for all of these different ones and the one that I was expecting. So let's see if this causes a timeout. And the thing to think about, like why this takes a lot of operations, is this is iterating over the array, and then inside of that iteration we're iterating over the array again. We are not iterating over the whole array because we're starting at the current index, but we're doing a lot of iteration, because essentially for every number we're looking at every number to the right of it. So for an array of like 10 million, that's a lot of iteration. Let's see. Okay, it runs for the sample tests, but will it run without the timeout? Drum roll, please. It's taking forever. My guess is not. It's trying. It's trying real hard. Execution timed out. And if you look at the instructions, it's basically because they're giving us an array of 10 million, and this is just taking way too long. Cool. So let's solve it in a different way. I think, as I mentioned, this will be the last kata that I do. I've been streaming for close to an hour and a half. This has been fun. Thanks for everyone in the chat. I say it like I'm going to be able to solve this instantly, but I have an idea. Really, we just want the function signature. This. Okay, so essentially what we were doing in the other way was like creating all of these pairs, like looking at this, and this, and then this, and this. So like we're comparing all of the values. But what if we keep track of every value that we've seen? So, and we can put that in an array. So like, let's just say, have seen? I don't know if that's a good name for it, but that's not in an object. And so like, when we come across the first value, then this will say like true. And then when we come across the second value, this will say true. And when we come across the third value, this will say true. But now that we're keeping track of every number that we've seen, we can do a single iteration, and basically on each number, we can say, okay, given this number, I need X value to get to the sum. Have I seen that value before? And if I have, just return that pair of those two numbers because I've reached the sum. Let me write that out in words. So basically let's call this a place to keep track of the numbers we have seen. And then we will iterate over the numbers. We'll say subtract current number from sum to get the number we need. Check to see if we've seen the number we need before. If we have, return the pair. And then if we haven't, we'll then just return undefined. Yeah, I think I should do it. Let's try it. So let's take a quick break. Last break of the stream. Whew. Yeah, so a place to keep track of the numbers we've seen. Let's just say this. It just feels weird calling it scene, like scene numbers, and that's an object. And so now we iterate over the numbers. While I is less than numbers.length, I plus plus. Oh yeah, I won't forget to make the clan. Thanks, Bob. And then subtract the current number from the sum. So let's create a variable called current number and set that equal to numbers at I. And then the number we need is sum minus current number, because that's going to give us the leftover after we subtract it is the number we would need to actually add to current number to create the sum. And then check to see if we've seen the number we need before. If we have, return the pair. If not, set number as seen. So check to see if we've seen the number we need before. So if seen numbers has a property that is the needed value, then we return the pair. So we would return an array where the first value is this. So let's say we've seen it, so that's that. Whoa. So the first value in the array is seen, and then the second value is the current number. Oh wait, no, that That's just true. Well, it's just need, because need would be the number that we've already seen. Like that. So if the object had that number in it already, that means it would be the first value in the pair, and then the current number is going to be the second value in the pair. Otherwise, set it as seen, and that's simply just going to be seen numbers at the current number is true. So we just saw the current number. We'll mark it in the object, go back around, keep doing this until we find the number we need, and then if we do have the number we need, we'll immediately return that. And this is a single for loop, so I think this will do it. And I think really the main difference being we're doing a single iteration. So in an array of 10 million, we're only going to go through that array once, and the earliest we encounter the sum, we're immediately going to return the array. So like we're not looking at all of the values together to see like which is the earliest. The moment we find a match, we know that that's the earliest in the array because we've seen those two numbers before we've seen any number after that. Let's try it locally, see if it still works. It does. I'm feeling good about this. All right. Sample tests. Good to go. Let's bring up that drum roll. It worked. Excruciatingly long list tests. Sweet. Let's submit it. Submit final. And let's also make that clan. So if I go to account settings, and then clan. Oh, I guess I already had it as something else, but not a part of that anymore. Let's call it Coding Garden. So if you're out there in the world and you want to join the Coding Garden clan, just make your clan name Coding Garden. I think I should do it. I have to save this. Update. Cool. And I guess on the homepage I should see anyone that's in my clan? I don't know. Cool. I'll go ahead and push up the challenges from today to GitHub, and then I'll post that link in the description. Any last comments, questions, thoughts, criticisms, praise, anything in the chat or from anyone watching at home or at work or on the bus or on the train or in bed, wherever you are in the world? I am tired. You work with a few galvanizers. That's awesome. Yeah, so I used to work at Galvanize. That's where I taught for like 2.5 years. Fun stream. Appreciate it. I had fun. I'm actually pretty exhausted, though. I had a long day of watching Netflix. Cool. Yeah, thanks, everyone, for tuning in. Some quick things. If you... Bob says we are now allies. You've joined the Coding Garden clan? There he is, Bob's Paradox. Cool. Kaizen Media's in there too? Awesome. Yeah, this will be fun. Okay, yeah, some quick plugs. If this is your first time joining the stream, well, welcome. I do this 5 days a week, so you can check out coding.garden, and this is my live stream schedule. When you visit the page, it'll be in your local time zone. And if you check out my YouTube channel, on the channel page itself, if you're a subscriber, well, I think even if you're not a subscriber, but if you're not a subscriber, you should subscribe right now. But on that page are upcoming live streams. So tomorrow morning, I'm going to do Morning Tea. This is where I just browse the web and talk about JavaScript news, and then maybe implement something I read about in JavaScript news. And then tomorrow evening is going to be a longer live stream where I actually code something up. I don't have the topic yet, but I will have the topic by tomorrow morning. But you can click set reminder on these if you do want to watch live. There's also a playlist for past live streams that I've done. And then playlists of code katas. This is the second one that I've done, but I'm going to add this video in there. Videos on Vue.js, some of the full live streams I've done, some of the morning tea episodes. You can check all those out there. And I think that's it. Kaizen says, cool, thanks. Was great. See you next time. See you next time, Kaizen. Aditya, I think that's how you say your name. Sorry if not. But hello. Welcome to the channel. So that's it for tonight. I will see you next time.